The concept of alien civilizations and their ability to harness immense energy from stars has captivated humanity's imagination for centuries. This idea, once confined to the pages of science fiction, has become a subject of serious scientific inquiry, especially in recent decades. As our technology and understanding of the universe have progressed, we've begun to entertain the possibility that extraterrestrial civilizations might be capable of constructing vast power plants in space, Dyson spheres, or Dyson swarms, that could harvest the energy of entire stars. These incredible megastructures, originally proposed by the scientist Freeman Dyson in the 1960s, were theoretical at the time, but recent discoveries have brought us closer than ever to confirming their existence. What's even more intriguing is that scientists have begun to identify dozens of stars showing signs of unusual emissions that could be linked to these extraordinary constructs. Could we be on the verge of discovering evidence of extraterrestrial life, or even making first contact with advanced civilizations? This is the compelling question raised by a series of recent studies that are transforming our understanding of the cosmos. One of the most exciting developments comes from two separate studies that have identified stars with bizarre infrared emissions, leading researchers to propose that these anomalies might be caused by Dyson spheres or Dyson swarms. These massive power plants, which could theoretically be used by alien civilizations to extract energy from their host stars, have now become a focal point of serious scientific investigation. The potential discovery of such structures would not only provide the first solid evidence of extraterrestrial life but also offer a glimpse into the unimaginable technological advancements of these civilizations. While the idea of Dyson spheres may still sound like science fiction to some, the reality is that these structures could be more than just theoretical constructs. They may be out there, waiting to be discovered. The first study that hinted at the existence of Dyson swarms focused on 7 red dwarf stars located within a 900 light-year radius from Earth. These stars exhibited an anomaly. They were emitting an unusually high amount of infrared radiation. Some of these stars appeared to be up to 60 times more luminous in the infrared range than they were in visible light. This was the first indication that these stars might be surrounded by something unusual, perhaps a Dyson swarm. A Dyson swarm consists of many individual satellites or solar collectors orbiting a star, harvesting its energy without completely obscuring the star. These swarms absorb energy from the star and re-emit it as infrared radiation, which is detectable from Earth. The infrared emissions observed from these 7 stars matched the theoretical predictions for Dyson swarms, making them strong candidates for further investigation. The researchers used data from a variety of astronomical surveys, including the Gaia, TESS, and WISE missions, to analyze the infrared radiation and movements of these stars. This data, collected over several years, allowed the scientists to identify the stars that showed the most promising signs of being surrounded by Dyson swarms. The results were groundbreaking. The infrared emissions from these stars were found to be consistent with the expected temperature range for Dyson swarms, about 25 degrees Celsius. While this temperature may seem relatively low, it is important to understand that Dyson swarms would not need to completely block the star's energy. Instead, they would harvest just enough energy to power the civilization's needs, and any excess would be re-emitted as infrared radiation. This discovery raised the possibility that these 7 stars could be surrounded by advanced extraterrestrial technology. However, the researchers were careful to point out that further investigation was needed to confirm this hypothesis. Other natural phenomena, such as hot planetary disks or interstellar dust, could also explain the unusual infrared emissions. Despite this, the results of the study were promising, and they provided a tantalizing glimpse of what could be out there in the cosmos. In a follow-up study, scientists expanded their search to include a larger number of stars, this time focusing on all spectral classes of stars within a radius of 6,500 light-years from Earth. This study used the same sophisticated astronomical data sources, including Gaia, TESS, and WISE, as well as additional data from other missions, to search for stars with unusually high infrared emissions. This time, the results were even more remarkable. The researchers identified 53 stars that showed signs of being surrounded by potential Dyson spheres or swarms. These stars included not only red dwarf stars but also larger stars, some of which were similar in size to our Sun. The fact that such a wide range of stars showed these unusual emissions suggested that Dyson spheres or similar megastructures could exist around stars of different types, not just red dwarfs. This was significant because it implied that alien civilizations might be using Dyson spheres or swarms to harvest energy from a variety of stars, including those that are much larger than the red dwarfs previously identified. The discovery of 53 potential Dyson sphere candidates within a 6,500 light-year radius of Earth is a game-changer. It suggests that we are not just looking at one or two isolated stars with strange emissions, but rather a widespread phenomenon that could be occurring across vast swathes of the universe. If these stars are indeed surrounded by Dyson swarms or similar structures, it would mean that advanced extraterrestrial civilizations are much more common than we previously thought. The sheer number of stars with unusual infrared emissions also raises the possibility that we may be only scratching the surface of what is out there. As our search methods improve and we continue to refine our techniques for detecting such anomalies, it's likely that even more potential candidates for Dyson spheres will be found in the future. The importance of these studies cannot be overstated. For decades, scientists have speculated about the possibility of detecting extraterrestrial megastructures, massive, artificial constructs capable of harnessing the power of entire stars. These structures, known as Dyson spheres, were first proposed by the theoretical physicist Freeman Dyson in the 1960s. Dyson suggested that an advanced civilization might build a shell or swarm of satellites around its star in order to capture its energy output. The idea was based on the notion that as civilizations advanced, they would need ever greater amounts of energy to fuel their technological growth. By constructing a Dyson sphere or swarm, they could tap into the nearly limitless energy of their star, securing an almost infinite energy supply. Dyson's concept was groundbreaking because it introduced the idea that extraterrestrial civilizations might be detectable not by radio signals or other forms of communication, but by their energy consumption patterns. The search for Dyson spheres, however, has been complicated by the limitations of our technology. In the past, it was difficult to detect the faint signals that might indicate the presence of such megastructures. However, recent advances in space telescopes and data analysis techniques have made it possible to identify potential Dyson spheres with greater accuracy. The Gaia, TESS, and WISE missions have provided us with incredibly detailed data on the movements and emissions of stars, allowing scientists to identify anomalies that might otherwise have gone unnoticed. This is why the recent discoveries of stars with unusual infrared emissions are so significant. They represent the first concrete evidence that we might be on the brink of discovering extraterrestrial megastructures, structures that could revolutionize our understanding of the universe and our place in it. But what exactly is a Dyson sphere, and how might it work? There are several different types of Dyson spheres, each with its own advantages and challenges. The most famous design is the Dyson shell, a gigantic, solid shell that completely surrounds a star. This design would allow a civilization to capture all of a star's energy, but it would also pose significant engineering challenges. A solid shell would need to be incredibly strong to withstand the forces of a star's radiation, and it would require an enormous amount of material to construct. For these reasons, the Dyson shell is often considered to be an impractical solution for energy harvesting. A more practical alternative is the Dyson swarm, a collection of independent satellites or solar collectors orbiting a star. These satellites would capture the energy of the star and either use it locally or transfer it to a central location. The advantage of the Dyson swarm is that it is more flexible and stable than a solid shell. The individual satellites would not need to be connected to each other, making the entire structure easier to build and maintain. Moreover, because the star would not be completely obscured, the Dyson swarm would allow for better cooling and energy management. Dyson swarms are also more adaptable to different types of stars, including red dwarfs, suns, and even more exotic stars. The flexibility of the Dyson swarm design makes it one of the most likely candidates for extraterrestrial energy harvesting systems. Another possibility is the Dyson bubble, a collection of translucent structures that are held in place by radiation pressure from the star. This design would be even more flexible than a Dyson swarm, as the bubble could be maintained using the star's own radiation. However, simulations have shown that controlling the stability of a Dyson bubble would be extremely difficult. The structure would be prone to instability, and it would require advanced technology to keep it in place. Despite these challenges, the Dyson bubble remains an intriguing possibility for alien civilizations that have mastered the manipulation of radiation pressure. Of course, these are just a few of the many possible designs for Dyson spheres. There are countless variations and combinations of these basic ideas, and we can only speculate about the kinds of technologies that advanced alien civilizations might use. In fact, it's possible that alien species have developed energy harvesting technologies that are completely beyond our comprehension. They might have discovered methods of manipulating exotic materials or using energy sources that we can't even imagine. Some researchers have even speculated that Dyson spheres could be invisible to our current detection methods, either because they operate at frequencies outside our current capabilities or because they are made from materials that are undetectable with today's technology. The search for Dyson spheres is not just about finding alien technology, it's about exploring the potential for humanity's future. If extraterrestrial civilizations are indeed harnessing the power of their stars, it suggests that such technologies are possible, and perhaps even inevitable, for us as well. In fact, the study of Dyson spheres may offer valuable insights into how humanity can eventually harness the energy of our own Sunday. As we develop new energy sources and technologies, the idea of building our own Dyson swarm or Dyson bubble may move from the realm of science fiction to practical reality. The implications of these studies extend far beyond the detection of alien megastructures. They challenge our understanding of what is possible in the universe and force us to reconsider our assumptions about the limitations of technology. If we are indeed witnessing the early signs of extraterrestrial energy harvesting, it could mean that we are not alone in the universe, and that the universe is filled with civilizations that are far more advanced than we are. This realization would change everything we know about the cosmos and our place within it. The future of humanity may be more intertwined with the search for extraterrestrial life and advanced technology than we ever imagined. The discovery of Dyson spheres, or even the confirmation that we are already detecting them, would be one of the most profound breakthroughs in the history of science. It would mark the beginning of a new era in our understanding of the universe, one in which the search for life beyond Earth is no longer just a dream, but a scientific reality. The ongoing search for Dyson spheres serves as a reminder of the limitless possibilities that exist in the universe. As our technology continues to evolve and our understanding of the cosmos deepens, who knows what other astonishing discoveries await us? The stars may hold secrets that we have yet to uncover, and as we continue to explore, we may one day find ourselves on the threshold of a new era of scientific exploration, one in which we not only detect extraterrestrial megastructures but also begin to understand the advanced civilizations that created them. For now, we can only continue our search, fueled by the belief that somewhere, out there in the vastness of space, the answers to our greatest questions are waiting to be discovered. The search for Dyson spheres is just the beginning of this exciting journey into the unknown.